All right, welcome back. Today we're jumping into a really cool formula in further calculus, the inverse tangent integral. Now, if you've ever seen an integral that looks something like 1 over x squared plus some number and just stared at it, well, you're in exactly the right place. We are going to break this down completely. So here's the plan. We'll start with the core formula itself. Then we'll walk through some examples together. After that, we'll get our hands dirty with some indefinite integrals, then move on to definite integrals and a pretty cool application. And of course, we'll finish up by looking at how this stuff shows up on exams. Sound good? Let's dive in. Okay, first up, the inverse tangent integral. Let's get right to the core formula. Seriously, this thing is the foundation for everything we're doing today. And here it is. This is our master key for today. The integral of 1 over x squared plus a squared, it turns into 1 over a times the inverse tan of x over a plus c. Now, the really important thing to lock in right now is how that a shows up in two places in the answer. You see it here as a fraction out front, and again, right here dividing the x. You've got to remember both. Now, you might be wondering, okay, but why? Where does this even come from? And that's a great question. It's not just pulled out of thin air. It's actually a super clever bit of algebra. You basically just factor out the a squared to make it look like a simpler problem. Then you do a quick u substitution, and boom. It transforms into an integral you already know how to do. It's a really slick proof. All right, next section, worked examples. You know, theory is great, but let's be real. The best way to get this stuff is to see it in action. So let's walk through a few together. Okay, first one up. We need to integrate 1 over x squared plus 25. Now, just looking at our formula, the first thing we need to figure out is, what's a? What do you think? Well, if you said 5, you're spot on. See, a squared is 25, and we always just take the positive square root, so a is 5. And once you have that, the rest is easy. You just plug a equals 5 straight into that formula we just learned. And there you have it, 1 over 5 inverse tan of x over 5 plus c. Couldn't be more straightforward. Okay, ready to level up? This next one has a little twist. We've got 1 over 2x squared plus 3. That 2 in front of the x squared, that's not in our formula, is it? So what do we do now? This example is so important because it teaches you the #1 trick for handling these tougher problems. And here's the secret. You have to factor that coefficient out. Just pull that 2 out of the whole denominator. That leaves us with a 1/2 out front of the integral. And inside, we have x squared plus 3 over 2. And just like that, it looks exactly like the form we know how to solve. Our new a squared is 3 over 2. We find a, and then it's back to just using the formula and cleaning up the result. Okay, let's move on. Time to master these indefinite integrals. We've seen the method, so now it's all about building that muscle memory. We're going to run through some problems from exercise 8b. And yeah, we can speed things up a little now. These first couple are pretty much just pattern recognition. You see x squared plus 9, you know a squared is 9, a is 3. Bam, there's your answer. You see 16 plus x squared, a squared is 16, a is 4. It's really just about spotting that a value and plugging it straight in. Okay, now stop and really let this sink in. This quote right here, this is the golden rule. It is the key to unlocking almost every tricky version of this problem you'll ever see. If there's a number in front of x squared, your first move, always, is to factor it out. Seriously, make that your mantra. And here's that rule in action. Look at this problem, 1 over 4x squared plus 3. So what do we do first? Yep, factor out that 4. That pulls a 1/4 out front and leaves us with x squared plus 3/4. Now it's easy. Our a squared is 3/4, we find our a, plug everything into the formula, and then just take your time simplifying those fractions to get the final answer. See how that works? Moving on. We've pretty much nailed the indefinite stuff. So now let's take it a step further with definite integrals. This is where we get actual numbers for answers. Plus, we're going to see a really cool real-world application of this whole thing. Okay, so when you see a definite integral like this one, going from 0 to 3, it's a two-step dance. Step 1, find the integral, which we already know how to do. That's 1/3 tan inverse of x over 3. Step 2, plug in the top number, which is 3, then plug in the bottom number, which is 0, and subtract the second result from the first. And when you work that all out, since tan inverse of 1 is just pi over 4 and tan inverse of 0 is just 0, we get this beautiful exact answer, pi over 12. And that's a really key idea here. We're not looking for a messy decimal from our calculator. We want these clean, perfect answers written in terms of pi.
Okay, check this out. I told you we'd see an application, and this is a classic. This formula isn't just for solving abstract math problems. We can use it to find the volume of a 3D shape, specifically the shape you get if you take this curve and spin it around the x-axis.
So we grab our standard formula for volume of revolution, pi times the integral of y squared. We have to square our y function, and when we do that, the square root conveniently vanishes, leaving us with 4 over x squared plus 1. And wait a minute, look at that integral. That's our guy. It's just a special version of our formula, where a is equal to 1. How cool is that?
All right, last section. Time to get ready for the exam. You've seen the theory, you've seen the practice problems. Now let's see how you do with a real exam-style question. I really want you to pause and give this a shot yourself before I reveal the answer. Ready?
Here you go. Find the definite integral from 0 to 1 of 1 over x squared plus 1. Remember, this is just that special case we just saw, where a is 1. Go ahead and work it out. So, how'd you do? The integral is just inverse tan of x. When you evaluate that from 0 to 1, you get inverse tan of 1 minus inverse tan of 0, which gives you pi over 4. This is a super famous result in calculus, by the way. It's one of those that's really worth just committing to memory. Okay, one last thing to think about before we finish up. This is a big one, and remembering it will save you so many marks. What do you think is the #1 most common mistake people make when they see an integral like this? You guessed it, it's forgetting to factor out that coefficient in front of the x squared. People get excited. They see the x squared plus a squared pattern and they just dive in. But remember, the formula only works if you have a plain, simple x squared. If you can burn that one step into your brain, factor first, then you've absolutely got this. You've mastered this integral.